Astronomers around the world are locked in a race to solve one of the greatest mysteries of the 21st century. They have discovered an extremely strange star. They call it Tabby's star. Tabby's star appears to have something enormous in orbit around it. From time to time, this object passes in front of the star and causes its light to dip.
You have to understand, we see millions of stars in the sky. Tabby's star is the only star out of all of these that we've seen this happen.
All stars vary to some degree, but no stars vary as sharply or as rapidly or as irregularly as Tabby's star does.
What could be blocking the light from Tabby's star? One theory stands out. Is the star being gradually encased by an alien civilization with a thirst for large-scale construction?
I cannot overstate what kind of scales would be involved in creating an object that could encompass a star. It's just really, really hard to imagine.
So what's got reputable scientists talking about alien megastructures? The story begins with a simple but baffling observation made by astronomer Tabby Boyajian. Tabby is the first scientist to discover the bizarre behavior of this star. Previously, it went by the catchy name of KIC 846-2852.
This is an image showing the stars around KIC 846-2852. And if we zoom into the center here, this is the star, the most mysterious star in the galaxy.
Tabby uses NASA's Kepler telescope to study the star that now bears her name. This innovative telescope is built to detect the faint shadow of distant worlds as they pass in front of their home stars.
The idea behind the Kepler mission is so elegant because it's so simple. You take an area of the sky and you just stare at it for years. When you see a small planet going across its star, the light dims, but in a regular pattern, again and again and again, and then you know you found a planet.
In just 9 years, the Kepler mission discovers over 2,000 new worlds. Most planets block out less than 1% of their parent star's light. But when the telescope looks at Tabby's star, it sees dips in brightness on another scale.
Most of the time, the star is at normal brightness. But then about 2 years into the Kepler mission is the first really big drop we saw, which is like 15%.
A drop in brightness of 15% is enormous. But 2 years later, the team captures something even more astonishing.
Over here on the far right, you can see we have this huge complex of dips. The star goes nuts here. The brightness is fluctuating in manic ways. The deepest one here goes to over 20%. And this is huge. We've never seen anything else like it.
The dips don't last long. Each event spans just a few days, but the drops in light are enormous. What causes this star to radically dip by over 20%? As the sun rises over Mount Wilson Observatory, Tabby can use the solar telescope to show us why such deep dips in the star's brightness are so unusual. Because with this telescope, she can demonstrate just how big an object would have to be to create such enormous dips in light.
Roll my sleeves up. We're going to control the sun. Here we go.
The telescope above Tabby's head projects a live image of the sun. If this projected image were Tabby's star, what percentage of the star's light would the planets we're familiar with block out?
So if you had an Earth-like planet, it would look something like this. This is a ball bearing here, and it is blocking out a very tiny fraction of the star's light.
The Earth may seem big to us, but compared to a star, it's tiny. It would block out just 1/100th of a percent of Tabby's star's light. What about the biggest planet in our solar system? How much starlight would Jupiter block?
In the case of a Jupiter-sized planet, we would have something the size of this coin that's passing in front of the star, blocking out about 0.5% of the star's light itself, which is still a pretty small fraction of the overall light output of the star.
Even enormous Jupiter is too small to account for Tabby's star's drops in brightness. So how big would an object have to be?
So you would have something along the size of this, and this is blocking a huge amount of light. We're talking up to 22%.
If this were a planet, it would be almost 373,000 miles across, a world almost 100 times bigger than Jupiter. That would make it the largest planet ever discovered. But for physicists, that's a problem. It turns out it's impossible for a planet to grow this big.
The biggest planet you can get is roughly Jupiter-sized. If you start adding more mass to Jupiter, it won't get bigger, it'll get denser.
A dip in the star's brightness of 22% is just too big to be caused by a planet.
Scientists know that something is blocking out the light from Tabby's star. If not a planet, what is it? The race to find answers is on. With no obvious natural suspect, some astronomers begin to investigate unnatural explanations.
The behavior of Tabby's star was so weird, and we had no idea what was going on, that we were willing to entertain almost anything, including aliens.
There is a secret in the scientific community. Even though we can't say out loud that we believe in aliens, I think we all have a sense that maybe there is life out there.
But why would an alien race want to build a structure big enough to block out more than 20% of their star's light? A clue lies in the heart of Nevada. Spread out over 2 square miles of desert, stand 10,000 reflective panels. Each bows to worship the sun. Steve Croft is an alien hunter.
Scientists love a good head-scratcher, and Tabby's star is really one of the biggest mysteries to come along in astronomy in the last few years.
Steve believes that this solar facility might be a miniature version of the megastructure that could be blocking Tabby's star. Could advanced aliens have built a monstrous solar farm around the star to harvest energy from it?